Thank you very much, Alexei. You introduced me better than I ever could have. I'm not very good at marketing myself, so I should take some of that. All right, yeah, so this talk is about work I did at Twitter this summer about validating changes in type checking on Codebases with SemanticDB. Yeah, okay, so I'll explain what all this means, and I'll talk about SemanticDB. So let's get started. So this talk is, the context is automated code rewrites at Twitter. Twitter uses a tool called ScalaFix for its code rewrites for different purposes. One of the purposes is improving code health, just what quality of code we have, migrating library usages across the code base, among other use cases. So we're going to focus on a specific rewrite at this talk, which is ExplicitResultTypes. And this rewrite adds return types to all definitions that are visible outside the source file. So as an example, we have public-facing member definitions. It's useful for simpler static semantic analysis tools because they don't have to infer types. They can just use whatever type we're giving to the definition. And then this is also a cornerstone for RSC, which is an experimental Scala compiler focused on compilation speed that Eugene will talk about at Scale by the Bay. And it uses this explicit result types to kind of speed up compilation. However, it turns out that this rewrite can influence the behavior of the type checker in ways that don't show up in sources. And we'll kind of examine what that means. So as an example of this rewrite, we just have a simple Scala object. It has this field, big decimal 100, sorry. And it's not annotated. And then after the rewrite, I just have in light green whatever the rewrite adds. The rewrite doesn't really clean up whatever the type that is added. That's just the fully qualified name. But hopefully you get the idea. It's basically just annotating the type. So the only difference between these two files is pretty small. That makes the scope of this project not too big. So the problem that we're trying to solve is how we can compare potentially changed semantics in two code bases beyond just syntax or source diffing. Right? You can look at diffs, just regular text diffs on your source files, but this doesn't tell you the difference in behavior for things that do not show up in the source files, which we will talk about. So here, just a simple diagram, we just have the original sources, we apply the ScalaFix rewrite, and we have our rewritten sources. So one of the parts of the solution we had is SemanticDB. SemanticDB is a data model for semantic information, such as symbols and types about programs in Scala and other languages. So it's a protobuf-based format, and it supports an entire ecosystem of tooling. So we have compiler plugins for Java and Scala that generate this. They kind of produce a SemanticDB. We have tools that kind of operate on it, diffing and comparison tools, like the ones that I was writing. And then we also have IDE-like semantic analysis tools. So for instance, we have a code browser that you can see as a web application. And you can click on things to go to where they're defined among other IDE features. And then this also supports ScalaFix for rewrites that depend on semantics, as opposed to just syntax. So maybe the rewrite needs type information or something similar. So as part of our toolchain, we use SemanticDB Scala C, which is the compiler plugin for Scala that generates SemanticDB, as mentioned earlier. So here's just an example of what SemanticDB looks like. This is a printout from one of the SemanticDB tools, which is, I think it's Metadiff, that prints, just shows what SemanticDB looks like. OK, so here I just correlated what we see in SemanticDB with the actual source file. So we have the same source file as before. We have the % object, which SemanticDB sees as an object that extends any ref. We have the field that it is declared. We have kind of different sections of the SemanticDB file, right? We have like a symbol section. It describes whatever symbols we have. It has occurrences, which have a line number. They have a line number and then whatever kind of that piece of the file is referring to, like the actual symbol. We have a convention for how to uniquely identify symbols that can be seen outside the source file. And then finally, we have a synthetics field, which is going to be those semantics that I talked about that don't actually show up, but they do affect the semantics of the program. So in this case, we have big decimal. When you write parentheses like that, it's not just big decimal as a function. It's actually an object with an apply method. So that apply gets added by the compiler. So for the purposes of this talk, Scala synthetics, it's an overloaded term. But here it just means fragments of expressions that the compiler inserts that the user didn't write. And this is actually semantic behavior that we cannot catch with the source diffs, right? So this includes implicit expansions, inferred types, macro expansions, and for loop desugarings. So as an example, we're calling, the important part here is we're calling last on an array. And by default, arrays are not actually collections. So Scala wraps it in this ref array ops thing that turns it into, it wraps like a wrapper around it that supports the collection operations. And then this is basically what we see in the SemanticDB. So SemanticDB has a parallel model for Scala synthetics. And we added basically a tree protobuf message that describes these synthetics. So what a synthetic is in SemanticDB, it has a source position. And then it also has the tree that describes what fragment we have. So like for the previous example, we have the source position from 69 to 4, 69 to 34. And then we have the original text. And then also, you can see ref array ops of string around the star, which means we're wrapping the original text in this method call. And just to summarize, it's basically a standard typed abstract syntax tree. So to call this ref array ops, we do an apply on a type apply on predef.ref array ops, and we apply it to the original tree. So now, with the tools we've talked about, we run SemanticDB, or we run the Scala compiler with the SemanticDB plugin on both code bases, and this produces two sets of SemanticDB that are parallel to the sources that they were run on. And it includes synthetic information, right, which is the information that doesn't appear in the sources, but is the information that we actually care about in terms of semantic diffing. So the next step is we just want to diff this, right? So the next thing we did was implement a command line tool called Metadiff, and it works very similar to just a regular text command line diff. So it doesn't show any output if there's no diff. Otherwise, it shows text output that describes what are the semantics that have changed based on the SemanticDB. So for the context of Metadiff, what it does is it looks at synthetic trees at different positions. And if at a certain position the synthetic trees are the same, then for our purposes, this means that the semantic behavior must be the same for them. So this is how we're able to basically catch if there's any changes in semantic behavior. So the logical step would just be to run Metadiff on these two sets of SemanticDB. But this actually doesn't work because if you consider code that is written before and after the explicit result types rewrite, for instance, the positions are all wrong, right? Because we added snippets of code, like all the positions that SemanticDB uses to describe the semantic information are off. So if we just compare the original files, the original SemanticDB files, it doesn't even make sense. It's telling us the wrong differences. So what we actually need on top of this is a tool that finds correspondences between the positions, which we call a reconciler. And our implementation just shifts back the positions in the new SemanticDB so that maybe there are differences in semantics, but at least the positions are the same. They correspond to each other, right? And we can do this because the rewrite is relatively small. It's relatively local, so that there can be other semantic implications, but for most pieces of code, this works fine. So finally, here's our entire toolchain. We have, we have the original sources. We compile a SemanticDB plugin. And we have the new parallel SemanticDBs. We run the reconciler, which takes all the previous information we have. And then it produces new source SemanticDB that is more similar to the original source SemanticDB in that it only describes changes that we think are semantic changes. And then we run Metadiff on that. And that gives us our semantic differences. So finally, we've been able to capture any differences that haven't showed up in the code between the two source trees with this entire toolchain. So we are open source. The two repositories of note are Scalameta and RSC. Scalameta is kind of the project that SemanticDB is a part of. That is a suite of metaprogramming tools for Scala, and RSC is the compiler I mentioned earlier that Twitter is developing. Yeah, so thank you very much.
Questions? What are examples of other rewrites other than insert the type annotation? What would be some interesting examples of those?
OK, so the question was, what are some examples of rewrites aside from adding explicit type annotations? I guess for the scope of this project, mainly because the reconciler is very dependent on the behavior of the rewrite, we focused on this specific rewrite. As for other rewrites, I guess that question applies to Twitter more generally. I'm actually, I don't think I can recall any other rewrites that we were using. Like there are applications, but I'm not quite sure. Maybe Eugene can help answer this question.
I would ask a question. So we're all, in a state of high anxiety in Scala community about transition to Dati, Scala 3, right? So people wonder how it will affect in Codebases. Verizon has, $1 billion investment in Scala 2 Codebase and companies like this. So we all need tooling. So how can this help us in transitioning to Scala 3?
Yeah. So the tooling around SemanticDB, so the progress, as far as I know, is that it works for Scala 2.11, 2.12. The nice thing about SemanticDB is that the format is general enough so that it can express any version of Scala that we give it in the future. I don't think that we have implementations that plug into Dati that actually spit the semantic information, right? So once we do have that semantic information, then we can use tools like this. And this will tell us, basically, based on our model of what we think SemanticDB, like what the semantics that SemanticDB expresses, that model will be able to tell us if there's actually any differences in your code after you've migrated to Dati. So you could definitely apply it for something like that.
More questions? I want to ask Eugene, do you want to ask a question? Max? OK, cool. Well, thank you very much, Max. We really appreciate it.
Thank you.